Okay, in this video I'm going to start putting the MicroPython parts together with some rough code. As I did this, I ran into a few challenges, so I've extended this video into 3 parts, so none of them are too long. The first 2 parts are going to cover the code, and then the third one's going to cover some debugging and optimization I did. The diagram on the screen at the moment shows you my thoughts on how I'm going to build the MicroPython application. Basically there will be a main loop running continuously that's called main.py. It gets run automatically with MicroPython devices on boot up. This loop will perform 3 main actions. So the first action, it's going to perform all the MQTT based communication with Google IoT service. This will retrieve the config defined in the IoT service for the device and save it to a file called uprobeConfig.py on the device. This contains a list of network tests or the probing that's going to go on. I'm going to call the network tests probes as I go through this probably. That will be performed on the device. By the way, I spent a long time to work out the name for uprobeConfig.py. I don't know whether it's the greatest, but it's the best I've come up with so far. It's looking to represent the things that are going to be done by the probe application, so the MicroPython code. After getting the latest probe config, it will send the results from earlier network tests or earlier probe or capability tests that have been performed back to the IoT service, and at that point it'll disconnect the MQTT connection to the Google IoT core. Okay, number 2, so the number 2 box there. So after performing all the MQTT stuff, it's then going to actually go through and perform the network capability tests. Those tests again are described in the probe config JSON. There's a property called probe list that contains all the probe tests that are going to be performed. The results of these capability tests get stored as JSON files in the results file folder, and that's shown on below the number 2 process. There'll be one file produced for each test that's performed, and again the MQTT part of it, number 1, is going to be reading those results and sending those results one file at a time, or the information in one file at a time, up to Google IoT core. As it transfers each of those results, it's going to remove the result from the results folder. Then finally, number 3, we want to make sure the whole thing doesn't get out of control and run network tests too often. So we don't want the probes to look like DOS attacks or denial of service attacks by having continuous network tests running against target hosts. So I've introduced a governance mechanism which is fairly simple. It'll just delay the next loop before going back and perform the steps 1, 2 and 3 again. Delay it by whatever time I've specified. Again, that's part of the probe config information, and I probably don't want this to loop more than once every 5 minutes, so I'll probably set a default for that governor to make sure the loop doesn't occur more than once every 5 minutes. Quick side topic before I get to the main probe code. So I found out the best way to get configuration information from Cloud IoT is a built-in approach that relies on setting up a topic called config, which happens by default when you create a new device, and having that topic read in by the MQTT code on the client. This shows how I initially set up that config information. So I go up to Google Cloud Platform, open IoT Core, Once there, I see my registry microcontroller, so I click on that. I go into my registry. Under that I can look at the devices associated with that registry. I've still just got probe 0 set up. Then I click on probe 01, and from here I can select update config, and here you can see the config information that I've set up. I've set it up as a JSON string, so it's based on text. Let's have a bigger look at this. So for initially I've set it up with a property called a governance setting of 300 and a probe list, which has the two probes that I want to launch from the ESP32 client. Okay, now let's have a look at how that config information set up on the Google Cloud IoT Core system makes it down to the ESP32 client. Just a note here, so you saw me set up that the config information manually so far. I just typed it into the dialog provided in the Cloud Console. But longer term, what I'll be doing is creating the Angular client that's going to manage this whole thing up on the web, and it's going to set up that that config information for each probe. So I won't be doing it manually, but let's carry on. So we've got that config information set up on the Cloud IoT. Down in the MQTT client on the ESP32, so this is referring to the code that I set up in video 7. So I have the routine called main_py. It's got an underscore because I don't want this to run by default on boot. When I set this up for real, I'll set it up as main.py. So this code in the main event loop will be started every time the ESP32 boots. So one routine we have in there is get MQTT client. So this sets up the object representing the MQTT client for my probe. So there's various things that goes through here. The piece we're interested in is where a callback gets set up that's going to process any messages that we are subscribed to. So we're setting up a callback called onMessage for this client. The other thing we need to do is set up subscriptions to the messages we want to get. So it's setting up subscriptions for the config and the commands topic, and the config's the one we're interested in, and is the one we set up earlier. So let's see what onMessage does with these messages coming in from these various subscriptions. So we go back to near the beginning of the main_py code, and there's the onMessage function. It's really just got a couple of lines of code in it, or two main things it does. So first it sets up a string representing the configuration topic, so devices / name of my probe, which will be probe 1 that it got from the config.py file, and then /config. So that's the messages or the topics that I'm interested in. Next we have an if, just to make sure we're only processing topics with that name. If we see one of those, then I'm going to use this routine which I've created, we'll have a look at in a sec, called uprobeConfig.save, which is going to save JSON representation of any message that's associated with that topic. The message gets decoded so it's in string format before it gets passed to the save routine. So next let's have a look at uprobeConfig and see what it's doing. Earlier on we saw the overall design, so part of what the MQTT processing does is save the probe config information to this probeconfig.json file. Then later on in stage 2 of the main loop, it's going to read probeconfig.json to get the list of probes or tests to perform. I'm encapsulating the interface to this probeconfig.json file into a library, so let's have a look at that. So this is the probe uprobeConfig.py library. So it does two things. It provides process to save a string to the probeconfig JSON file, and then one to get the JSON that's in that file and return it as an object. So in the save, we go to the top level directory. We open the probeconfig JSON file for writing as text. We write the probeconfig JSON parameter that was passed to the save. This is will be a string. One thing we have to do, and it took me a while to debug to find out why it wasn't saving the string, is we have to flush the buffer to make sure it actually gets written to the probeconfig JSON file, and then close the file. And then similarly over on the get, we get by going to the top level directory, we set up an empty object for object probeconfig. Check whether the probeconfig JSON file exists. If it does, we open it, in this case read text. We read it. We use the uJSON, which is a library that converts strings to and from objects to JSON. So we've got a string, JSON string O, so we're going to convert it to an object. So the object probeconfig that we set up here, and returns that object. Also in this library, I've got it commented out, but I put my tests in here as well, so we can have a look at running the test. So I'll comment that out. I'm going to go to the PyCon console, connect up, and run that routine. So here we see it's written it out, retrieved it, and the get shows the object that's now on the file. If we want to check what's in the file, is to use this program uPyCraft. You can get it on the web. So I'm going to connect to the board through that, and under device, this actually looks on the device, and there's an easy way of actually seeing the files on the device. I found it a lot easier than trying to pull back files one at a time. There's a nice way to sort of cruise around the actual ESP32 device and see what's there. So we just made a uprobeConfig JSON file. Let's open that, and it's as I'd expect. It has the object defined as a JSON string in the file. Okay, we'll now have a look at how we deal with results. So in the MQTT process, the other thing it does is send results up to the IoT core. Results are held in a folder called results. Under the results, there's one file that has the results from each of the network tests or capability tests or probes are in our results file. Those are read by this MQTT process, sent up to the IoT core, and then that particular result is deleted from the folder. So let's see the library that I use to help manage this results file I/O. So I put together a library. It's called uresults.py. So this manages the I/O associated with handling results. This has a few more functions in it. So there's a function called reset. So this basically clears out the results folder. So useful when first starting up, just to make sure all the old results are cleared out before we start. It checks that a results folder is there. If there's any results files inside that folder, it removes them one by one. If there's no folder, then it creates a new one. There's a function to add results. So it opens a file that it creates. The file name is actually based on the utime ticks. So this won't be unique across boots, but it'll be unique within any boot of the ESP32. So that's all we want, is a unique file name created within the context of a boot cycle for the ESP32. That name is given to the file. It's write text as the open mode. It writes out the results information, which comes as a JSON string. Again, must remember to flush the buffer to make sure the data is actually written to that file, then close the file. There's also a function to list all the results in the results directory or folder. There's a function to get the contents of a results folder as an object, and there's a function to remove a particular results file. So again, I've got a test down here that I can uncomment and try out. Let's try that out. Let's run that. So it's added it. It shows me the contents when I do a get on that particular file name. There's the name of the file. So again, it's been given a name based on the U time, and then it's removed the file as well. So that looks like it's working. Let's look at how that's used up in main.py. So in the main.py, there's this main loop that it goes through, and the part that processes the results is this part here. So it gets a list of the results by calling uresults library that I was just showing you. Gets the list of all the results that are there for each file in the results list. So it gets the file name. Does a get, uresults get, so remember that returns an object that is the representation of the JSON in that particular file. So it's put into result. We print out some debugging information, flash some LEDs. Now this is the important bit. So now main topic, we set up the main topic to be written out to the cloud IoT. So this is where the results will go up on the Google Cloud Service. Then we do the publish, and then once that's done, we remove that particular file. So you see here the uresults library. I'm calling the remove function. Does that, so I'll just repeatedly do that until it's processed all the results that are in that folder, and then we disconnect from MQTT, which is the end of that first part of the main loop code. So in the next video we'll look at process number 2 and 3 in the main loop, and then we'll run our code and see what problems we'll have. And I know we've got some, so the third video in this part of the blog will be about debugging and optimizations I have to perform.